Let's take a look at how to assemble your Samurano V1 kit as a sumo wrestling robot. Let's get started by looking at what's included in your robot kit. You should have a 4-speed gearbox, a battery pack for holding 6 AA batteries, a bag full of electronic components, a Arduino Nano or compatible CPU, a printed circuit board, a set of O-rings to act as the tires for our robot, some 3D printed wheels, a base, a bracket to hold the battery pack in place, and some pins to tie the battery bracket to the base. If you have all of these components, you should have everything you need besides a soldering iron in order to get started on putting your kit together. Now let's take a look at assembling the gearbox. Your kit includes the Tamiya 168 gearbox, and the one that we're going to be using, or the configuration we'll be using, is the 38.2:1 gear ratio. When it comes down to putting something like this together, it's always helpful to have some way to organize the small parts, because this does contain a fair number of small parts. You can use something like an egg carton, or even a soldering mat like the one that I have here. Let's get all the parts out of the box now. Now that I have all the parts laid out, you'll notice that I actually have 2 additional motors here. I pulled these out of the electronics bag that came with the kit because we're actually not going to use the motors that are included in the gearbox, as these motors are not typically designed for the voltages that we use on the Sumo, and they underperform when it compares to the ones that we've also included in the kit. So I'm going to set these 2 aside. I always like to keep any of my spare parts and put them back in the box, so try not to destroy the box while you're going through. In the box you'll see an instruction pamphlet. This one here, we want to make sure that we're using the 38.2:1 gear ratio as is outlined here. So it should look similar to this. When it comes down to putting these together and taking a look at those instructions, you'll notice on the instructions themselves, it actually outlines here that you're supposed to apply grease to all of these darkened areas. So we have the idler shaft, the drive shaft for our robot itself, the surfaces of the gears, and in addition to this, I also recommend that you place grease on the mating surface here and here of these gears, as these gears have a tendency to rub up against one another as your gearbox is spinning. And if they do so enough, they can actually weld to one another without some kind of lubrication in between the surfaces of the gears, in which case your gearbox will start making a ton of noise and ultimately lead to damage to the gearbox. To start off with, we're going to remove the parts from the plastic housing here that they come in. To do this, you can simply break the parts off by wiggling them back and forth, or my preference is to use a set of side cutters, or flush cutters in this case, and cut them all free. The reason I do this with flush cutters is because it gives a much cleaner cut. We're not going to use this bracket here. This bracket is used to attach the gearbox to a different kind of base. Although if you redesign your Sumo base, you might need to utilize that bracket, or you might wish to utilize that bracket rather, when it comes to assembling your robot. For now, I'm going to put that back in the box. I'm going to set these parts aside because the first thing I'm going to do is use the drive shaft and idler shaft and get those prepared for assembly. In order to do this, it helps to have a ruler, such as the one that I have here. And we need to get this nut. This is for the drive shaft. And from our small parts bag, we have this little set screw. I find it easiest to put the set screw on the included Allen key and then start threading it into the nut before trying to put it onto the drive shaft. And for this particular assembly instruction, we need to have this approximately 13 millimeters in from the end. So we've got 10, and there's 13. So we'll tighten that down. And I'm going to prepare the other side as well. Next, to prepare the idler shaft, the plastic bushing that this one wants is the long yellow bushing. And the long yellow bushing needs to be 7 millimeters in from the end. So what I like to do in order to do this is I like to grab one of these brass bushings and use the brass bushing as a guide to help me press this in. And let's see, what does that give us? That'll probably give us about 4. Yes, and we need to have 7. So now we'll just gently push this on. Got 6. And 7. And now prepare the next one. All right, so now we have our 2 drive shafts and our 2 idler shafts, all with their parts in place. We can then grease these up and place all of the eyelets and everything together. So in my case here, I'm going to start with this side of my gearbox, and I'm going to drop the eyelets in. And I'm going to grab the center of the gearbox. Try not to drop the eyelets in the process. And I actually did that to the wrong side, so I'm going to try it on the other side. If you're careful, those eyelets will stay in place, even if you do put them in on the wrong side to start with. And now we will grab our grease, and I'll give instructions as I'm putting together the one half of the gearbox, and then just speed up the video for the other half. As I mentioned before, apply a little bit of grease to this little flat on your gearbox on both sides. I actually avoid greasing up the teeth of the gears until the end. We're going to add a bit of grease on here. As this side of the gearbox only gets 1 gear. Little bit of grease on the short side. More grease on the long side. And we can place this one in. And for this gear, this is the drive gear. It has the notch in it. We don't actually need to add any grease to it. And in fact, I put this gear in place before I should have. So we'll place our drive gear on. When you place your drive gear on, make sure to have that notch facing up so the set screw is still accessible. And this one here is our crown gear. You can tell by the way that the teeth are facing. We're going to add some grease to both sides of that crown gear as it's going to rub. And then in this case, we actually need to use this little metal spacer. And then finally, place the halves of gearbox together. Insert the screw and screw the gearbox together. And now we have an assembled half gearbox. When you run these, it should feel very smooth, pushing this back and forth. If it's not feeling very smooth, then you've missed some spots for greasing. Once we have the whole gearbox assembled, then we'll add grease to the surface of these teeth and spin the gears some more, which will allow us to work that grease into the gearbox itself. And now I'll speed up the video while I assemble the other half of the gearbox. So now that I've greased in between all the gears and I've put them all together and screwed the gearbox together, I like to go through and run these gears manually a little bit by hand first. It should make a nice little whirring sound if you have everything lubricated properly. Next, we're going to add the drive gear to our motors. Now, the correct motors to be using for this are the motors that have the two tabs sticking out for the back, for the power. And the direction that we want this gear to face, normally you would put the gear on in this orientation. However, for these motors, because they have a bit longer of a shaft, we're going to place the gear on the opposite way. So you want the gear to face this direction, and use a hard surface to press that gear onto the shaft until it is flush. We're going to do that on both motors. And then we're going to lubricate this gear here. I like to add 3 generous globs of grease. Because this gear is going to be spinning at a fairly rapid rate. And then looking at the top of the gearbox, which this is the top, the part with the crossbar here, that's the top of your gearbox. I like to align the red marking on my motor with the top of that gearbox and just press it in to make sure that it lines up. And it's a little bit hard to see on the camera here, but it should mate fully with that crown gear. And you'll see this is fairly challenging to spin manually at this point. Now you can grease up your gearbox before putting your motors in, or after your motors are in. It's entirely up to you. The last piece that we need to add though here, once we have our motors in place, is this clip here. This is just a spacer to help hold the motors. And it should be able to slide right on in like so. Then we're going to flip this over, and I'm actually going to grab one of the wheels for our kit, press one of the wheels on, now that that wheel's on, it gives me a little bit more leverage. So I'm going to add a little bit of grease here and here on all of those mating gear surfaces. In this particular configuration, it's optional as to whether or not you add grease to this outer gear because it's not actually doing anything other than acting as a spacer. So then we're just going to drive this a bit until all the grease has worked its way in. And it should sound fairly smooth like this. When you have it greased up appropriately. Once we've done that to both sides, our gearbox is now assembled. You can set all of your extra parts back into the box so that you have them available for future use. Now let's take a look at assembling the PCB. Before we do any soldering, it's important to take a look at some proper handling procedures for holding a PCB. To start with, you always want to avoid touching the pads on the PCB itself, as the oils from your fingers can actually lead to improper adhesion of the solder that you're using to put the board together. In doing so, this could lead to cold solder joints or a failed PCB by the time you're done. Instead, it's better to hold this PCB by the edges as seen in the video here. Now the first thing that we're going to start with assembling on this board is the resistors. And I actually have a resistor color code sheet that I just got off of Google so that we can make sure that we're grabbing the right resistor for the right location. Resistor 1 on the circuit board here is a 330 ohm. So that means that we should have a orange, brown with a gold band at the end here. So looking at our resistors here, you'll notice that this one here is orange orange, brown, gold. So this is our first resistor. I'm just going to grab a set of pliers here and bend the resistor legs. And then place it into the holes on either side of R1 here. And press it all the way down to the board. And then in order to get this to stay in place, I like to just bend these leads out a little bit. And it kind of holds the resistor in place so it doesn't fall off the board. The next one we're going to do is we're going to line up and put in our 100 ohm resistors. So looking at this chart here for 100, we should have brown, black, brown. And indeed, I have some resistors here, brown, black, brown, with gold band being a 5% tolerance. And the 100 ohm resistors, we've got R2, R6, and R4 that use the 100 ohm resistors. So I'm going to pull out 3 resistors here. I'm going to set any unused parts off to the side. And you don't have to use a set of pliers to bend these. You can just bend them by hand. One thing I do recommend, however, is that when you go to place your resistors, as you can see here, I've got the gold band in one particular direction, right? So on my board here, the gold band is towards the rightmost side of the board. If I'm placing more resistors in this direction, I'd make sure that all of the gold bands are facing the same way. And the same for when we put in all of our resistors down here. I'm going to put the gold band facing up because then it's going to line up with the text the same way as the other resistors have. It's not a requirement to do this because resistors are polarity insensitive, so they don't care about polarity. But by making sure that our resistors are all placed in the exact same way, we're paying a little bit more attention to what it is that we're doing, and there's a less likelihood that we would put the resistor in the wrong place. Now, if you're building this as a sumo kit, it's not 100% necessary to have R6 and R7 put in place, because R6 and R7 are used in order to control the current going to the Q3 sensor, which we don't need for the sumo wrestling. However, I'm going to be installing all of them so that I don't have to install that later on, because it's a lot easier to put them in now than it is to do it later once you've got other components attached. And I'm actually going to save the 4.7K ohm resistors for last. And I'm going to solder up these 4 resistors first before I install them. Now, another way you can hold these devices in place when it comes to getting ready to solder them is you can actually put a little bit of tape over top of them in order to hold them in place so they don't move. What I'm going to do is I'm just going to bend the leads as I had before and place the circuit board down on my soldering mat. So when it comes down to soldering, we want to make sure that we've tinned our iron. So you'll notice right now my soldering iron is very dull in color. That's because it needs to be tinned. So tinning just adds a little bit of solder and then you wipe it on the sponge to clean it up. Now you can see it's shiny. It conducts heat a lot better when it's freshly tinned. So to solder these in place, you want to make sure that the iron is touching both the lead and the pad. And you're just going to hold the solder there until it starts to melt. and then drag your soldering iron up the length of the lead, and that'll make sure that you get a nice little volcano shape to the solder. If you don't have that nice little volcano shape, then it's a sign that you end up with what's known as a cold solder joint, and you don't end up with proper adhesion of the lead to the pad, which can lead to all kinds of failures in the future. You should also see when you flip your board over that the solder should actually create a volcano on both sides. So I've actually under soldered these. I didn't hold the heat there long enough, so we can just add a little bit more. Hold the iron down a little bit longer. And that'll help guarantee that the solder has wicked all the way through. There we go. Now you can see that the solder has come through on both sides. And then next we want to come across and we want to trim these leads up. I like to use a set of flush cutters because it gives a nice close cut. And then we have less likelihood of things snagging or causing shorting at the end. When it comes down to soldering, there's a couple things you have to watch out for. When we have pads that are close together like this, we need to make sure that we don't add too much solder, because if we add too much solder, we can end up with a solder bridge. This means that the pads are actually going to conduct across one another, which could cause damage to the controller, depending on how your system is designed. On the front of the board here, you'll notice that we have these pads labeled SNT1, and you'll notice that they have these kind of D shapes, and there's a gap in between. This is because this is a device known as a solderable bridge. If you're not using the barrel connector, then we need to solder this together to connect the ground plane so that our circuit board will function. Otherwise, we have no path to zero. Similarly, underneath our processor, we have a cuttable trace. So you can take a X-Acto knife and cut these should you wish to disconnect that particular signal. For example, here where we have SVO1, by cutting this trace, we'll disconnect servo 1 from the processor itself, allowing us to be able to use this for some other purpose if you want to customize your system. Now I'm going to move on to soldering in these last 3 resistors. Then I'll show you the final color code for this one, and we'll move on to the next set of components. Next, we're going to use the 4.7K ohm resistors, and these guys here should be a yellow, violet, red. So yellow being 4, violet being 7, and red being that times 100. So yellow, violet, red, and gold. And we've got 3 of those, so we'll put those in place and solder them in. Now, when it comes down to soldering, one thing that you want to keep in mind is that you want to hold the heat on your component for the least amount of time possible in order to create a good solder joint. Now the reason for this is twofold. Number one, you can actually damage the pads on your circuit board by holding your heat there for too long. And number two, while these resistors are not heat sensitive, there are many different types of heat sensitive components, some of which we're going to end up using on this kit by the time we're done. This is why I recommend that you start with the resistors first, because they're fairly tolerant to mistakes. Should you make a mistake, it's handy to have a device such as this one here, which is called a solder sucker. And what it allows you to do is by pressing down the plunger here, you can apply heat to the solder and then press the button, and it will suck the solder away from the joint, allowing you to redo your solder joint if you accidentally add too much solder, or to be able to clean out a hole in a circuit board to replace a component. Once you have all your resistors in, your board should look as pictured here. The next component that I recommend that you move on to are the monolithic capacitors that we have. These are going to be installed in positions C1, 2, 3, 4, 5, 6, 7, and 8. All of these are what's known as monolithic capacitor. These are polarity insensitive, so it doesn't matter which direction you put them in. And the purpose of these is actually to filter out any electrical noise generated on the circuit board that could cause inaccurate signaling. So I'm going to speed up the video here and place all these in and solder them all in place. In addition, before I get to putting those in place, an additional tool that's handy to have is one of these. This guy here is what we call a set of helping hands. Now the helping hands allows us to grab a hold of the circuit board and act as an extra pair of hands when it comes down to working on soldering or putting components in place. One thing that I definitely recommend that you do is apply some heat shrink, or as I have here, electrical tape, to the grips on the helping hands to make sure that they're not going to abrade or scratch up your circuit board when it comes down to working on something like this. Let's get to installing all of those capacitors. And now that I have all of these capacitors in place, I'm going to use my helping hands to hold the circuit board in place while I solder these all in. So by trimming those leads that I've already soldered in place, it allows me easier access to the leads I need to still solder. And as mentioned before, I actually have a problem on my circuit board here. Right at this point here, you can see that I ended up creating what's known as a solder bridge. In this case, my two sets of leads from the two capacitors are touching one another, so I need to correct this. In order to do so, I'm going to use that solder sucker to remove the solder, separate the leads, and then resolder them back in place. And now we'll resolder both of those leads and go around to do some touch-ups. So now we have all of those components in place. We've got our resistors, these monolithic capacitors, and now we're going to start moving on to some of the components that are a little bit less tolerant to heat. So the first one that we're going to work with here is we are actually going to grab the socket for our processor and for our jumpers. Now these are a component that it's very important to make sure that you have properly lined up. So what I'm going to do is I'm going to grab some tape, and I'm actually going to tape them to my board while I flip it over and perform the soldering. Now the risk here with these, if you get them too hot, you can actually melt the pins and they may not make proper connection. So I'm using just a little bit of electrical tape here. You could use something like masking tape or Scotch tape even. In the electronics industry, we typically use what's known as Kapton tape, although I don't happen to have any, so I'm going to be using electrical tape instead. And so I'm doing my best to make sure that those are straight. And what we're going to do is we're just going to solder one pin on each header and then confirm that they haven't shifted before we solder every other pin in place. Okay, so with one pin on each header soldered in, right, so I soldered this pin down here on each header. I'm going to take the tape off now, and we're going to verify that these are still straight and aligned as they should be. And in fact, you can see how these two headers have pulled apart from one another. This is a problem. We want to make sure that they are straight. There we go. All it took was a slight adjustment. Now we've got them running perfectly parallel to one another. These two are leaning in. We've got this one out of place. There we go. Got our headers back where they should be. So I'm going to solder these in place. I'm just going to use some electrical tape again, same electrical tape as before, to make sure that these are going to stay while I solder one pin on the opposite end. And there we go. You can see that the headers are nice and straight and they're aligned with one another. So now I can go through and solder every pin all the way along, being careful not to cause any solder bridging. And there we go. Now the sockets for our processor are all soldered in place. The next thing that I recommend that you do is move on to soldering either the LEDs for the downward facing line following sensors, or move on to soldering your bridges between the upper and lower PCBs. I'm going to work with the LEDs next. So the LEDs that I'm talking about soldering in place are these QRD1114 sensors. These actually are an infrared sensor, so we've got an emitter and a receiver. And they're actually going to work by being soldered to the edge of the circuit board. So my recommendation for putting these in place is to trim the leads right about the middle of where you see a little flat here. So I'm going to be trimming my leads right about here. And here. And then these are going to go in the Q1 and Q2 positions. So Q1 being over here and Q2 being over on this side. And I find that they work the best when they're pressed right against the bottom of the board. So what I'm going to do is I'm going to lay this down on the table. I'm going to line this up, and I'm going to get one of the pads soldered. Something that you have to watch out for on these is that the LED is not pushed out of the housing. So these LEDs, both the emitter and the receiver, need to be tucked into the housing here. If you have them sitting too far forward, what will happen is they will actually see one another and falsely detect a line. Or in this case, the edge of the sumo ring, because we're configuring this for a sumo wrestling robot. So I'm going to use one finger to hold the LED in place. While I heat up the pad. And flow the solder on. Double check that the LED is flush on the side here and pressed up. And then we can move to the back and solder it in place. One other point that I didn't mention before is these LEDs are facing the right way around when the label is facing up. So you need to make sure that the QRD1114 is facing up. Otherwise, you have your emitter and receiver backwards, and they're not going to operate properly. Next, let's set up all those board-to-board jumpers. So the board-to-board jumpers are actually the components that go from here to here, because we're actually going to cut these three supports out so that we can bend this board and have these two at an angle to one another. And in order to make these fit, what you're going to do is you're going to grab a set of pliers, bend at a 90-degree angle, like so. And then you can measure up and mark where your second bend needs to be. For me, I'm actually lucky enough that my pliers fit pretty much right in between. So I'm just going to grab a hold of my wire with my pliers here, bend it up, and this should fit right into these two holes. Providing that I've bent this correctly. Oh, need to bend them in slightly. And there we go. So then you're going to solder these in place. My recommendation for setting these up is I recommend that you solder the outside two in place, then cut out this center support, solder the center in place, then cut out the outer two supports, the left and right, and then solder all the bridges in place. And one thing to note about these is that these bridges are actually a structural component to your robot. So it's recommended, unlike most components on the board where you only solder from one side, it's recommended on these to solder on both sides of the board, as the strength of the robot itself is going to come from making sure that they have a solid connection on both sides of the board. Otherwise, you could rip the pads right off your board and your robot could fail. So now that I have solder on both sides, I can go about putting in the rest of those bridges and removing the center supports. Now that we have all of these bridges in place, we can move on to the next part. The next part that I would recommend soldering in place would be the power switch. So the power switch, again, doesn't matter which direction it goes. However, this one is one component that is very heat sensitive. So my recommendation when it comes down to this one is to do it close to last, like we're doing now, so that you're experienced with soldering quickly, as if you get this too hot, you will melt the switch. I also recommend soldering one lead of the 3 leads on the switch, then trimming all 3 and soldering the other 2. Next, we'll move on to the LED. Now, the LED is a polarity sensitive component. If you put it the wrong way around, you'll actually burn it out. So on the housing of the LED, you'll either see a flat, like this one has here. So you'll see that it's mostly round. And then on this side here, there's a flat side. Or there'll be a notch, or the shorter of the 2 leads all indicate the negative side of your LED. So we want to make sure that we line it up with the correct polarity for our circuit board. And again, we're going to bend those leads out and solder it in place. So the positive side needs to be over here. LEDs are also fairly heat sensitive, so try and limit the amount of time that you're applying heat to the component. Now we're down to 4 components left to put onto our board. We have the electrolytic capacitor. This capacitor filters out the power going into your CPU, which we also have to solder up, by the way. And it is most definitely polarity sensitive. If you get it backwards, it will explode. So make sure that the negative side is pointing away from the little positive marker on the board when you go to install it. I'm actually going to put in the voltage regulator next, which the voltage regulator is marked by this REG. And you'll notice that there's a large white line. This indicates the heat sink of the regulator. So we want to place that in there, like so. And we're going to solder that in place. This is a 5-volt regulator to take the 9 volts coming in from our battery pack and drop it down to 5 volts for our controller and control electronics. A word of caution when you're soldering this component in place. The ground lead, or the 0-volt lead or return lead of your voltage regulator, is tied to this heatsink, and it will get very hot as you're doing the soldering. So try and avoid touching that to prevent from burning yourself. Trust me, it doesn't feel good. Next, we're going to solder in our motor controller. The motor controller has a lot of pins to go in place. We want to make sure to line up all of these pins so that they all fit in the holes properly and get our motor controller nice and straight. If you don't get your motor controller straight, it'll be really hard to apply the breadboard later on should you choose to add something there. Next, we're going to solder on the capacitor. So making sure that the negative lead, the short lead, is facing away from that positive symbol. That leaves us with the two probably most heat intolerant components that we need to solder onto the board itself. And then finally we'll get to soldering up our processor. But first, let's move on to these components here. We have the battery harness. Now, although there's nothing that will really get damaged if you hold the heat on too long, what happens here is if the wires get too hot, it will actually melt the insulation back and you have the possibility for shorting. So we need to be quick when it comes down to soldering these components. One thing that I like to do with this is I like to give these wires a twist because I don't like it when they tangle up on one another. So I'm just going to twist all the way down the wire. One thing to note when you're twisting, be very gentle when twisting the wire up near the top of this connector, because you can actually rip the wires off of the terminals internally. And we're going to leave approximately this much wire untwisted because the next step is to take these and put them into our circuit board. So you'll notice on the circuit board here, we have a square terminal and a round terminal for our DC in. The square terminal is the positive terminal. The round terminal is the negative. Beside them, you'll see two holes. The purpose of these holes is to pass the wire through acting as a strain relief before we feed the wires in to these two holes and solder them in place. Be sure to press the wires down all the way so that they make contact, the insulation makes contact with the top side of the board. And then you can come to the bottom side of the board here and solder them in. Remember, solder these in as quick as you can so that you don't melt the insulation on the back side of the board. Then, if you wish, you can pull these down and finish the twist on your wires. Now we have our battery terminal attached to the board. At this point, I'm going to solder in that shunt marked SNT1, because I'm not attaching a barrel jack. If the barrel jack was here, the barrel jack actually has a jumper between terminals 2 and 3 and would create the connection for the negative for us. We don't have that, so we're going to touch both pads here simultaneously. And I actually have too much solder there, so I'm going to take some off with my solder sucker. And redo that. The last thing to add on here is the wiring harness for our range finding sensor. And this one here, I'm going to do the same thing and twist the wires up, and then I'm going to place them into these 3 holes here. The order in which these need to be connected is red down here, followed by black in the middle, and yellow at the top. So pin 1 is yellow, pin 3 is red or positive to our sensor. If you get these in the wrong order, you will cook your sensor and it won't function. So let's twist those up and get them installed. Again, be very careful when twisting at the top because you can damage the connector. You don't have to perform this twisting. This is just my preference. So again, the order of those wires is yellow at the top, black in the middle, and red at the bottom. So here's that color order again. And then we can twist those wires. And the last component that we're going to solder up is going to be our processor. I most definitely recommend that you save this for last because it is very finicky and very easy to make a mistake. And it's also very difficult to fix if you do make a mistake. Now, when it comes to soldering these in place, my recommendation is that you place the pins in and place the processor onto the base. And then we're going to solder the 4 corners in place, remove the processor, and solder up the rest of the terminals. The reason that we do it this way is that by soldering it while it's attached to the board, we're guaranteeing that these pins are going to be straight and that we will be able to remove the processor later on. Now, as long as I've soldered all 4 corners, I should be able to very carefully remove this and solder everything up. And that's what happens when you don't remove it carefully. You can end up pulling the pins out of the header. So to fix this, you can either pull the whole header out or ever so carefully put the whole thing back together and solder all the pins in place while it's on the Sumo, which is what I'm going to do. I'm going to leave it in place and solder all the pins. You can see that I've got a couple pins that I under soldered, so I'm going to touch those up. And then at this point, if you have assembled your motors and gearbox, we can attach the motors and gearbox to the rest of our robot. Now, a couple things to note about this. The motors and gearbox, these tabs, need to face the ground. So that means that your gearbox, if it's facing this way, will have your board slot in like so. We just need to line up these tabs with the slots. My motor tabs appear to be bent. So I'll gently straighten them. And your motors and gearbox should slide in like so, where all of the tabs from your motors protrude through these points. We're then going to solder these in place. The last thing that we need to add is this sharp rangefinder sensor. And there's a couple things to note about this sensor. Number one, when you tip the sensor over, on the back here, I've already pre-trimmed these. However, on the back, you'll notice that there's 3 leads that are used for the connector itself. These 3 leads, if we put the sharp sensor where it's intended to go on the robot without trimming them off, or without putting electrical tape over to isolate them, will actually cause a short on this 5-volt rail, as this jumper here carries the 5 volts to the lower portion of the board. So that would cause our sensor to short out if we were to place it on top here, because that lead will end up touching this point. So it's my recommendation that you either put some electrical tape or some sort of insulating tape in between this sensor and the robot itself, or to trim these leads as I have here. So when it comes to installing this, we're going to use these screws, which actually thread through the sensor itself. And you'll notice that they are snug on the sensor, so we actually need to thread them through. And they will actually bite into the circuit board behind the sensor when we go to install them. So let's zoom out and you can see me installing this here. So I'm going to get the screws started on my sensor. I'm going to take my circuit board and bend it back here. Because this is the direction that our board is supposed to be facing. And I'm actually going to take the excess cable here from my sensor, just kind of wrap it up on itself, because I don't want another robot to grab a hold of that cable and snag mine. Then we'll plug in the sensor. And finally screw it in. Now that we're done with our PCB and our gearbox, let's move on to final assembly. I like to start the final assembly by attaching the base for the robot. To do so, we're simply going to use these screws and nuts that came with the gearbox, and we're going to pass them through the hole on the bottom plate here that we've got. And it looks like I might need to thread this in with a screwdriver. So I'll just get this started here. My recommendation when it comes to putting these in is to get your screws started through the base, then get the nuts started on both sides, as you see here, and then finally tighten everything up. Now, since for this configuration, I've chosen to use the frontmost position for our gearing combination because we're using the 38.2 to 1 gear ratio, we actually need to remove this tab here and this tab here from our base. So I'm going to use my set of flush cutters to remove that. Next, let's put the wheels together. Assembling the wheels is as simple as grabbing your O-ring, stretching it over the wheel hub that's been provided, and then lining up your wheel onto the shaft. Press it down on a hard surface, and they should just slip on. Finally, we have the battery installation. In order to install the battery, your kit should include some double-sided foam tape, that you can simply take the double-sided foam tape, place it on the battery bracket that's included, and I'm going to trim mine off so it doesn't stick over the edge. Connect your battery, and if your robot turns on as mine did, flip the switch so it doesn't run off on you. And then I like to set up my battery so that the cable coils in neatly back behind the battery pack here. The orientation of the battery pack is entirely up to you. Then all we need to do is take that bracket and the pins that we've provided you with, slide the pins in through the hole here to hold the battery bracket in place, and press your battery pack firmly up against that bracket. Do your best to make sure that this is centered, because if your battery pack is off-center, it might put you at risk of losing a match or two. And now the Sumo is complete.